Hello, and welcome to the Poultry Nerds podcast, where feathers meet fun. Your podcast hosts are Carey Blackmon and Jennifer Bryant. Together, they work hard to bring you the latest news and information from the exciting world of poultry. Sit back and get ready for some exciting interviews and some foul facts on this episode of Poultry Nerds.
The DECVAA, what is that?
That means that I have a European specialization in veterinary anesthesia. So I went to vet school in Germany, where I'm from, and that's the DMV. It's a doctor of veterinary medicine or Dr. MedVet. And then I decided to focus on the academic side of academia with a stronger focus on teaching, a small focus on research, and a quite small focus on clinics. That is the PD. So that's a 3-year program that is comparable to a master's in education. It's quite specific for German-speaking countries. And then I had my specialized training in veterinary anesthesia. That is the DECVAA, and which means diplomat of the European College of Veterinary Anesthesia and Analgesia. And then the PhD is a regular PhD.
Oh, that's just normal, just run-of-the-mill stuff, huh? And then you made the mistake of sending me an email with your big, long signature on the email when I tackled you for a podcast interview.
That is correct. Yeah. I reached out because we couldn't figure out why they were not laying.
Are they doing well now?
They are doing incredibly well. And I'm really impressed on their dependence on the game birds layers feed. Because we did what you recommended, right? We changed their light regimen. And so we changed coop position a tiny little bit and switched the food. And it took about a week and they started laying really well, an egg a day per quail. And then after, I would say 2 months, maybe, there was a switch up when we ordered the food and we got not the game bird layer feed, but normal game bird feed, which we didn't really realize. And the only reason we did realize this switch in food is because they stopped laying after about 10 days.
Interesting.
Yeah.
You got them straightened back out now, though?
Yeah. We switched food and now they are back in the game.
Yeah, I never recommend the game bird layer for the Coturnics. It seems like it always causes issues, but I do have it for the button quail because they need it, that high metabolism. They need it. I didn't bring you here to talk about your quail necessarily. We asked you to be here to talk about just the bird's respiratory system so we can get a better idea of how it works and why it's different from ours. Well, can you overview that for people who are new to birds?
Yeah, I can. I have to say that the respiratory system of birds it's from an evolutionary perspective quite impressive. Their gas exchange design is substantially more effective than ours. The only species that might be maybe a little bit more effective in that regards are fish, which is likely because they live in a really low oxygen environment. Mm-hmm. But what birds can do due to their very special anatomical design of the respiratory system is they can make gas exchange and they can uptake oxygen during inspiration and during expiration. And that makes them twice as effective as us. Just as a reminder, right, the way we breathe is we inhale and then our lungs expand from the negative pressure that our chest develops during inspiration, right, when we do this deep breath in. So the lung expands, which, if we want to simplify, it looks a little bit like one big balloon. So this balloon expands, oxygen enters, and then we make gas exchange, which is the transfer of oxygen from the air into the blood. And then we exhale, and during exhalation, we exhale the gas now that has not much oxygen left and a little bit of CO2. So our oxygen uptake is, when you look in the respiratory cycle, quite short. out of 1 minute, it's about 10 to 12 seconds that we effectively take oxygen into our blood. And that seems to work quite well for us. So what birds do in contrast is they have, and some people might have heard that, right? They have a set of so-called air sacs, a total of 9. That is pretty similar amongst all birds. So they have 9 air sacs. And so 4 in the front, and then 1 at the side, and then 4 at the back. And what happens during inspiration is the gas enters the lung like it would with us, and it enters all air sacs. And during inspiration, it flows by a tubing system. So bird lungs are not a big balloon, they are more tubes. And while it flows by these tubes, they do gas exchange, right? So there's blood in the one direction, there's one tube, and air in the other direction, that's the other tube. And while they basically pass by each other, oxygen transfers from the air into the blood. And as I mentioned, so all air sacs get stilled during inspiration, but the back air sacs, the caudal ones, they basically get all the air that bypasses the lungs, whereas the front air sacs, they get all the fresh air that has not bypassed the lung. So at the end of inspiration, where the bird already did some gas exchange via this tubular system, there's now one set of air that is filling the caudal air sacs that is basically used. And there's a fresh set of air that is filling the cranial, the frontal air sacs that is still fresh. And then during expiration, the gas from the caudal air sacs gets exhaled, and the gas from the frontal air sacs again bypasses the lung while it's getting exhaled. So the bird is able, with this very special and quite fascinating anatomical design, to fill the lung with fresh air and make gas exchange and uptake oxygen during inspiration as we would, but also during expiration. So they basically constantly have fresh air bypassing the blood, and they can constantly uptake oxygen.
Super interesting. I followed all of that.
Call myself taking notes.
So the reason for the air sacs is what?
So the main reason for the air sacs is it cools the bird down, right? There's always air, which is at best room temperature. So it cools the bird down. And the other reason for the air sac is it's basically a constant reservoir of fresh oxygen. And these are the two main mechanisms of the air sacs.
Does it have anything to do with their ability to fly, like their buoyancy or anything like that? Or no?
No.
Okay.
A bird could fly without this complex air sac system. That is purely mechanics and their wings. So the air sacs really do these two main things.
Okay.
Which is a huge advantage when it comes to oxygen uptake and to meet their high metabolic needs. Because it's a quite energy consuming event, flying, it comes with disadvantages as well. Right? Because people could ask, well, there's such a strong evolutionary advantage of having this kind of lung or respiratory system. Why wouldn't all animals have that? And things that the birds can't do with their lungs, for example, is filter as precisely as we can do that with our very complex airway system. That's why we are much more robust when it comes to upper airway contamination, which might be something we want to touch later, right? Aspergillosis, for example. We have a much, much better developed airway immune system. The way our airways are built, they become very small and the airflow really drops from fast to really slow, which helps filtering all these particles out. So that is one big advantage of our airway system in contrast to birds. That's why they sometimes don't do well if they fly and have really extensive gas exchange. And another reason, what we do with our lungs that birds, for example, can't do, and that is relevant for me as an anesthesiologist, is we use our lungs to metabolize drugs, to get rid of them. For example, propofol, a quite popular or well-known anesthetic. The older ones of us might remember Michael Jackson and the propofol incident. So our lungs help us metabolizing propofols. Birds can't do that. So they are much more sensitive to certain drugs that require pulmonary metabolism. And then the third big thing that our lungs do is they store a lot of blood, basically a blood reservoir in case that we have to mobilize. And that is something that the birds also can't do. So it's a trade, right? We decided we have lesser metabolic needs, but we have a more robust immune system. We have a little bit of blood storage and a little bit of metabolism, whereas the bird decided I need oxygen all the time. And there is only 21% in the ambient air. So I need to do whatever it takes to make my gas exchange as effective as possible.
Okay. So 2 questions come to mind. One, I see people with birds that have enlarged air sacs and they use a needle to deflate them. What is that? And should you use a needle to deflate them?
Yeah. So sometimes air can be entrapped. For example, if we know this from ourselves, if we have chronic respiratory diseases, then over time our airways become lesser patent, lesser elastic. And then birds can develop so-called air trapping, which can inflate their air sacs a little bit. If that is the case, just deflating the air sacs might give some relief in the moment, but it's not really a treatment of the issue. And usually that redevelops quite quickly. Another thing that people need to be quite careful with is if you use a normal needle, not a special medical needle that is hollow and therefore allows the gas to basically leave the bird. If you just poke a hole in the air sac, you might risk emphysema development, meaning that the air might leave the air sac, but is still trapped in the bird. So it is usually best to use special equipment. If they are very calm and very quiet, you can try to do it yourself. But usually these birds do best if they are at least mildly sedated or well restrained, because entering and exiting with a needle, we always think it might cause a small hole, but if you actually enter a very inflated balloon with a needle, you will see that they erupt. And worst case scenario, you can actually burst the air sac. And that might be a death sentence for this bird, because then during inhalation, it would just entrap more and more air until they couldn't breathe anymore.
Okay, if you did nothing, could the bird eventually fix this inflated air sac itself?
Yeah, if it's not severe and you find the reasoning for this inflated air sac, for example, a respiratory issue, and you treat that respiratory issue, then there's a very good chance that the secondary symptom or problem, right, the inflated air sac, this meteorism, would then resolve once the underlying issue is resolved.
We're not sticking to my outline. You got me like all sidetracked and I'm wanting to think.
Yeah, I realize that.
The show's called Poultry Nerds, and this is actually really bringing out the geek inside of me, and I'm really getting into learning about this. And I would have never imagined that a bird breathing has 9 air sacs, and it's they're taking in and they're inhaling and exhaling at the same time. I would have never thought that.
It is, the concept is brilliant. Yeah, sorry, go ahead.
I was reading a paper last night as I was trying to wrap my brain around talking to you, and it said they actually inhale twice for the exhale. So the second
inhalation is a little bit longer. That's why they have this uneven number of air sacs, right? So they can make the inspiratory period very long, the expiratory period a little bit shorter, which is quite the opposite of how we breathe. I always tell my students, not now because now everyone is at alert, but during the next lecture, when some of them have forgotten, they should casually observe in a non-creeping way their neighbor and see how they breathe. And they will realize that exhalation takes a really long time. And then there's the pause, right? Then we do a brief inhalation or a deep breath, then a long exhalation. And the bird is much more linear, constantly breathing with a nice ratio of 1.5 to 1, right? With constant airflow, constant oxygen uptake, which is super effective. That's why they do so well, still quite well, right? At high altitudes. when the barometric pressure drops, we might still have 21% oxygen, but we have so much lesser oxygen particles, right? If you go up to Mount Everest, that's why we only go up there with an oxygen bottle, right? When the barometric pressure drops by 40% or so, we theoretically have 40% lesser oxygen available, which is a problem for us, but not for a bird. They do incredibly well in low oxygen environments because they are so incredibly effective.
Super interesting. Carey is just like grinning from ear to ear on the nerdy stuff here.
I can't help it. It's very interesting because he's sitting here talking about how they breathe faster and stuff. I think I'm real bad about going out and sitting in the yard where my birds are. I have chickens and quail, and I'll watch the quail and they breathe extremely fast, and my chickens do too. And I just never really thought about why, but now I realize that it's a lot more efficient and it works.
Yeah, it does.
I had a trivia question then before we move on to my next set of questions. So would a hummingbird breathe faster than, say, a big old turkey?
Yes.
Okay. All right. So one last question on this part of it. So we have a diaphragm, which squeezes our lungs, right?
Yeah.
So we don't have a diaphragm. So what's squeezing that air in and out?
The chest itself. The chest movement, and it's usually really well synchronized. It's usually really well synchronized with their wing movement, particularly during flying. That is something that many animals do. A horse, for example, when it gallops, it synchronizes its breathing to its strides, and the bird does the same because it's very energy efficient, right? They use the movement anyways, either to fly or to move forward. Why not using the movement also to move gas in and out? So they do this with their chest movement quite extensively. And because they don't have the diaphragm as their main respiratory muscle, which is an advantage from a body cavity perspective, right? Because therefore they have much more space for their air sacs. But it is a disadvantage, for example, when they have some kind of lacerations or wound. If we have a wound and it involves our abdomen, we can still breathe. We will have other problems, but breathing is not altered because the chest is still a very enclosed space. If that happens to a bird, they will start struggling with breathing. We will see this. Even small wounds, a bite wound, for example, they will start struggling with breathing much more than we would.
Interesting. Okay. So now let's talk about like respiratory infections, colds, that kind of stuff. So
yes,
mammals have tonsils and all other, I don't know, all the anatomy stuff that's all up in there to gather dust and keep our lungs clean. So how do birds keep that stuff out of their lungs and air sacs, I guess?
Yeah. And that is for birds a little bit more tricky, right? They have a lesser fine and lesser advanced developed immune system, but also pure cleaning system. So the first thing that birds do is when the air enters right through the nostrils and the nose into the trachea, because that is something that a bird has, like we have that too. They are very small cilia, right? They look a little bit like very small feathers that are all over the mucosa of the trachea. And they are in constant movement. And usually what happens when you inhale quite fast, and fast inhalation, when it enters a narrow space or a narrow tube, like the bird's airway, becomes very turbulent. So you go from a low to a high pressure. That's a little bit like a garden hose phenomenon, right? And you have the same amount of water and you just narrow the garden hose. You just increase the pressure. Same happens here. So you increase the pressure. This increase in pressure then hits the trachea wall and starts to become really turbulent. And this turbulence is quite helpful because it leads to the air having a lot of contact time with the airway wall while it's traveling downwards in a spiral. And then all the rough dirt and dust, some microbes and some very small particles are then caught by these cilia that are along the trachea wall. And they move constantly in waves. And the wave and the wave-like movement of these cilia always goes towards the nose. So these small dust and particles are then caught, and the cilia, while moving, move them back upwards. And then at the end, for us, that would be snot, is something that the bird can then cough out. And that is really important to keep the air that then enters the lung as clean as possible. Because the air sacs themselves have only very limited capacity for defense against either smaller particles or even bacteria, microbes, or viruses that enter. So the most effective way for the airway to basically clean itself up is a washout effect of fresh air. Therefore, it is important, right, for birds to either have a lot of access to fresh air so that they can constantly breathe. And that is why birds that can move more, right, that are not contained in small spaces, but can either move, or if they are supposed to fly, that they can fly or run a little bit to really activate their breathing system. That's why they usually do substantially better. And then the last thing that is really important for the immune and defense mechanism of the airway of avian lungs is they have a very special lymphatic system that if there should be any kind of transfer of particles or microorganisms, that this lymphatic system immediately filters that and transports it away before it can cause any kind of systematic or systemic damage.
Does it put it out as an exhale or filter it the liver? And
yeah, if once it enters, it would be filtered through liver and kidneys and then excreted, either via the bile and then with the feces, right, or as giving that birds don't have a lot of urine.
Okay, I'm wrapping my brain around everything. Come on, Carey, you got a question?
So I do. One of my questions involves avian influenza.
Yes.
I know that is a huge thing that hits a lot of different areas. And I have always wondered if a bird's nutrition did not help build their immune system, and if it was possible for them to not get sick because they had a really good immune system, or what's the science behind all that? How does that work? And is there anything that can be done to help prevent, or is it just one of those things?
That is a fantastic question and will require a little bit broader answer, because avian influenza, right, is a viral infection that mainly affects the airways. And this question is a brilliant question when it comes to viral infections that affect the airways, right? And now that we just barely left the pandemic with a strong association to airway infections, I think this topic is really broad, incredibly important. And to answer it, particularly for avian influenza, its target species, birds, yes, we can do certain dietary measures to improve immune function in general, and in particular when it comes to the immune function. We can't prevent fully infection just by nutrition. But as it is with us, the healthier the individual, the better we treat ourselves and our bodies, the more likely it is that we will either be able to immune fight the infection if the viral load is low enough and allows that. If the viral load is too high and exposure is just too aggressive, good nutrition will still help you to, if you're in overall good health, you might still have a much better chance to not become severely sick and maybe have lesser severe symptoms, faster recovery time. And a few specifics when it comes to immune function, right? So some vitamins and some minerals essential for a functioning immune system. Vitamin A, for example, is quite crucial when it comes to overall maintaining healthy mucosal surfaces. And that is in these kinds of problems, that's mainly the airway mucosa, right? This active cilia movements, that these are all healthy and doing well. There would also be the gastrointestinal tract when we would look at other diseases. So making sure that these animals are well supported Then what we likely know, vitamin E is a very important antioxidant that supports the immune function and that helps keeping immune cells healthy and active. It prevents a little bit immune cell degeneration. Same would be true for selenium. Then zinc is something that can support cell healing and cell function, and therefore theoretically also wound healing, right? If you just look at the immune system and vitamin and mineral support. But also, as we discussed earlier, an appropriate protein and energy level is really important, right? If you want to maintain a healthy flock or a healthy individual birds, that they are in good shape, that they have enough energy to fight off infections, that they have enough energy to regenerate proper if it comes to any kind of other diseases. And then because most of our organ systems are linked, it is also not unimportant to think about other organ systems, like, for example, the gastrointestinal system, gut health, and then overall, despite good nutrition, is then good housing. If you are concerned if your birds show any kind of symptoms, that you have a stress flip or a low stress environment, that they have time to properly regenerate. We can oftentimes translate a lot from us and our health to healthcare of animals. And we are not feeling well, it helps us to stay in bed, right? Proper regenerate, have a low stress, low energy environment, now and then get some fresh air, right? My grandma always said to air out your lungs, which is certainly true, right? The older I get, the more I realize I should have listened even more to what these smart people had to say. And that is something that you can absolutely apply to your birds as well.
Well, okay, so I would like to ask you a couple questions from a new chicken keeper's point of view. If chickens are sneezing or coughing a little bit or just sound a little bit raspy, I know what I do, but what would you suggest that they do first before they start to panic?
The last time I had a problem with my chickens, and it's likely that I would do the same again, I would reach out to an experienced chicken keeper. I believe that I can say that, given that I am in that profession. Mm-hmm. I think that many of my colleagues, as great as they are, right, as fantastic as they work and as well trained as they are, oftentimes just lack this last piece of experience, right? The true self-experience that is oftentimes needed to identify a problem proper, and then also to realize when is it appropriate to react and respond, and when is it appropriate, which kind of problems can I sit out and wait out. And back to my grandma, there are oftentimes a few household tips that carry much lesser side effects, are as effective, and maybe cause substantially lesser stress for your bird. Because the scenario that I'm always afraid of is, right, so I have a quail, and this quail has maybe a little bit of nasal discharge, or maybe breathe is a little bit different than the other quails. And if I now overreact and catch this bird and take it out of its used environment and away from its friends and drag it to a place, and then there's diagnostics maybe done, right? And maybe blood is taken and maybe a radiograph, right? As we usually tend to do that to get a better idea of the lungs. And then I get the advice to apply fresh air, a little bit of supplements and vitamins. Then I feel that you might have not only lost a substantial amount of money, but this poor bird also a substantial amount of energy that it might have invested better into healing. Right. The risk is always, if it's an infectious disease, you want to catch that early and maybe separate a little bit if you have this opportunity. But my advice will always be reach out to maybe your neighbor, your friend, or if you're a really fresh chicken father, to the person that you bought these chickens from, and ask for their advice, right? Describe it. Have you seen that before as well? What did you do? Did it work? Because experience is so invaluable. And if you get your birds from the right people, they will help you, they will follow up, and they know what to do. 100%.
So Just for your information, if one of my birds sneezes, I don't really even, I may not even notice until maybe a week later if they're still doing it. But all of my birds are outside. They're on grass. The chickens are fresh air, under sunshades, open to the elements. And if one of them just doesn't seem like he's feeling all that well, I'll just throw him out in the yard. Here you go, sink or swim. And almost 99% of the time they swim because they just needed the fresh air, the grass, the sunshine, just the natural elements. And it works.
A little bit of sun, a little bit of vitamin D, a little bit of warmth.
Mm-hmm. Yeah. I think people get so worried about predators that they tend to lock them up too tight. And that's a ventilation issue. My coops are mostly hardware cloth. They actually have very little solid structure walls. They're almost all hardware cloth. And people just freak out when they see them sometimes. But I don't get sick chickens. They constantly they're in the cold air. They're in the breeze. They get wet when it rains, just like they did 1,000 years ago.
That's how they get that vigor.
Yeah, I think you are 100% right. My sister has quails too. She still lives in Germany. They have about 40 quails. And I asked her what she does when it was so hot here in Pennsylvania in July. I asked her what she does if she would move them to into the shade, into the cold or a fan. She said, no, just leave these poor birds being birds. She said they have a nice way to get used to these temperature changes, she said, and they will just do fine, much better than if you now start moving them around and doing all kinds of things and try artificially to improve their welfare.
Mm-hmm. Yeah. Just let them be a bird.
Yeah,
That's
exactly.
right.
All right. So at what point then would you suggest, if somebody were to go to the medical route, at what point would it be prudent to go see a veterinarian?
I would, if you have a small flock of birds, because it's a hobby bird system. Otherwise, I would recommend that you should see a veterinarian quite regularly, right? If this is your income and you have thousands of layers, for example, like my brother-in-law has, they have a very nice laying farm with, I think, 28,000 chickens. And he has the vet there every week. And,
my journey.
Yeah. And
Nice.
they have a quite nice setup because they do this in North Germany, and they have, these birds have inside opportunities, but they are all free range. And they have the vet there quite regularly for water analysis, and they do a brief walkthrough, making sure that they are not an excessive amount of animals looking dull or something like that. But if I look at my very proud 4 quails, my 4 golden girls, I would say if I would be able to identify, which is tough because they all feed from the same area, but if I would identify one that is a true outlier, dull, not wanting to move when I engage them, maybe in lateral recumbency, excessive, very weird breathing pattern for a prolonged period of time, couple of days, I think then I would start seeking advice and maybe see a colleague of mine.
Sounds reasonable. Let's see. Let me look at my outline because we totally went way left.
We went rogue.
We did. How about, let's talk about a couple drugs then. So some drugs, most poultry drugs, I think are off label. And so people would, 7-10 days egg withdrawal, or don't eat that bird later on. What's your thoughts on off label drug use and egg withdrawal? That kind of stuff.
Yeah, that is a great question. So if, again, differentiating between a large producer, which should follow restrictions and should follow antimicrobial guidelines and guidelines for anti-inflammatory drugs, right, and anti-fungides. But if it comes to, if you have a small, flock, these are your birds and your hobby. I would say that when it comes to antimicrobials, for whatever reason you had to treat them, you should and you did circle back with your veterinarian, and your veterinarian tells you, I'm not 100% sure. I think with 2 or 3 weeks max, you're always at a really safe time frame. Most of them are really eliminated quite rapidly. The majority of them will be gone after a very few days. And if you want to play it truly safe, if you wait 2 or maybe 3 weeks, you are at a very good place. You also need to keep in mind, that just because the antimicrobials are maybe not fully eliminated, they are mostly eliminated. And then you need to always keep the ratio in perspective, right? The amount of antimicrobial that you will find in a quail versus the amount of antimicrobial that you would need for yourself, right? Given that there's a quite substantial body ratio difference. One example that we always use when it comes to body mass and effect, right, is the question, my dog ate a mouse that might have been poisoned. Do I have to be concerned? Sure, you should always be a little bit concerned, right? But in this case, the toxin and toxicity comes from the dose, which will be substantially lower for yourself. So for that, I would say between 2 and 3 weeks, you are at a really great place. If for some reason you were giving anti-inflammatory drugs, they have a very fast elimination rate. That is usually very few days. And I wouldn't be concerned about eating eggs or meat from an animal after 3 or 4 days when it comes to anti-inflammatory drugs.
Cool. Sounds good. Carey, you got anything else?
No, that was really awesome, though. I will say it was great to meet you. And I enjoyed hearing that explanation of how the respiratory system works on bird.
Yeah, it was really fun. Thank you so much for having me.
That was fascinating, actually. A lot more information than I expected.
Yeah, thank you very much.
Yes,
You're very welcome. I hope you have a great evening. And if I have ever a problem about my quails, you can be sure I will send you an email.
Thank you for joining us this week. Before you go, be sure to subscribe to our podcast so that you can receive the new episodes right when they are released. Feel free to email us at poultrynerds@gmail.com and share your thoughts about the show. Be sure to also give us a like and a follow on Facebook. Until next time, Poultry Pals, keep clucking, keep learning, and keep it exciting. This is Carey signing off from Poultry Nerds. Feathers up, everyone.